Hey everyone, welcome to the first video for Unit 4 on Analytic Trigonometry. This video is going to cover the basic fundamental trigonometric identities that we're going to use in conjunction with algebra skills to simplify trig expressions first. So an identity is basically an expression in trig that's equivalent to another expression. A lot of these we know already. For example, the reciprocal identities, we know that sine and cosecant are reciprocals. So even though there are 6 listed here, these are virtually saying the same thing. So sine and cosecant are reciprocals of each other, cosine and secant are reciprocals of each other, and tangent and cotangent are reciprocals of each other. We also have quotient identities, also known as ratio identities. These are basically saying that tangent and cotangent, which are reciprocals of each other, which we can see based on these fractions, are also equal to sine theta over cosine theta, or in the case of cotangent, cosine theta over sine theta. This is in relation to the fact that tangent is the opposite side over the adjacent side, and sine is the opposite side over the hypotenuse, and cosine is the adjacent side over the hypotenuse. So if we were to simplify that complex fraction, O over H over A over H, it would give us O over A, which is tangent, and the same thing over here. And then we also have Pythagorean identities, which are based on the right triangles that we use in trig. And it's essentially saying that the two legs squared and added together are equal to the hypotenuse squared. And again, this comes from elements of the unit circle and right triangles, but it's basically that sine squared theta plus cosine squared theta equals 1, 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. So whenever we're given some sort of trig expression, we want to substitute one trig expression for another in order to be able to simplify it, to cancel things out or combine them, things like that. So we're going to kind of take elements of algebra skills, like I said, that we've learned before, things like factoring, multiplying, and apply that to trig expressions. So the basic rules for simplifying a trig expression is that we want to apply trig identities where appropriate to try to get functions to match, or in terms of sine and cosine. That's just their sine and cosine are used in a lot of different identities. So oftentimes if we can get things in terms of either sine and or cosine, we can apply other identities to it to maybe get it to simplify. Or alternatively, we want to get things to match. Once they match, we can combine them, we can cancel them out, things like that. Once we've done that, we want to apply algebra strategies, like I said. So I've listed a bunch of links to review resources for things like multiplying polynomials, adding and subtracting polynomials, operations with fractions. All of these skills we're going to need to remember. And by the time you're done, typically your answer will be a single trig expression or a single number, like 1 or 0 or sine of x or something like that. So, so that's how you'll know when you're done simplifying. Okay, the last thing I want to mention in this video is that we can see that in Pythagorean identities, this is specifically for squared trig functions, but although it's not listed, if we were to square any of these, the same would be true. So sine squared theta is equal to 1 over cosecant squared theta. Tan squared theta is equal to sine squared theta over cosine squared theta. So if we see a squared trig expression in our problem, we're not just limited to the Pythagorean identities. But we'll talk more about that in class. Come to class with any questions that you have, and we'll take a look and see how it's going to appear in problems. Thanks so much, guys. Bye-bye.